Thank you. That's very nice to meet everyone. So let me share my screen. Uh, is it working okay? Can everyone see the screen okay?
Yep.
Yeah.
Thank you. So yeah, today I will give you short presentation on how I have been experimenting with using large language model to help me in data analysis workflow, especially on the Kaggle competition I do in my spare time, where I'm trying to build pipeline to perform the analysis quicker, given that's something I do as a hobby, and I try to use the LLM in order to do that faster, basically, so I can still do it in parallel of my day job, basically. And as a support for that, I will present a use case. So I often do the Kaggle tabular competition. So that's a monthly competition with synthetic data that Kaggle have been doing for a while. And I like to do those because in bioinformatics, I work a lot with tabular data. So I like to stay sharp on machine learning and new tools that arise with machine learning for tabular data sets. So a quick word of introduction about myself. So I'm a senior bioinformatician and data scientist. On my day job, I assist customers with biological data analysis, so clinical data analysis or biomarker discovery. And I like to compete on Kaggle in my spare time, and in particular for tabular playground competition that are relevant for my job. So I met Ricardo when I started to do a generative AI for data scientist course by Matt Dancho. So I started this course because when I saw the LLM, so in the world of LLM, there is a lot of marketing, there is probably a lot of hype, and there is also a lot of genuinely great application that we can do with this type of tool. So I took this course to learn a bit more about how to use a large language model with in combination with retrieval augmented generation, and to try to learn to build agentic workflow where not only the LM can help you synthesize information for PDF document, for example, but also take action with agentic workflow. And today I will focus on a sample application of using LangChain and prompt engineering, if you will, on how to help with exploratory data analysis, code generation, and monitoring discussion during competition to keep track of all the great ideas that are shared on the forum as well. So I have been using a large language model to automate my data analysis workflow so far. So when I engage with Kaggle competition, these are competitions that last for a month, the tabular competition. So generally, I try to have a workflow where I can quickly understand what the competition is about, create some exploratory data analysis quickly, often on things that are not for my domain. So I also try to use LM to help me with to get a bit of domain knowledge relative to the competition. And then finally, I try to use them to assist me with code generation. And I try to put that together in a workflow that is as reproducible as possible. So when I roll over competition to competition every month, I can get started more quickly into getting result and getting into the competition. So one thing I use this model for is first for the metadata summary. So on every Kaggle competition, the competition starts with like a brief description of the data set. So sometimes it will be a data set related to cells. It can be RAN or machine, so very wide variety of data set. The way Kaggle tabular competition work is they take existing data set from the platform, and then they use generative adversarial network to create synthetic data sets. So then people can practice their skill on tabular data set competition. And because these data sets have a large variety and often about things I don't know anything about, sometimes it can be like machine data, so more like engineering related, sometimes it's weather, sometimes it's insurance, depression, so extremely varied. So I use a large language model to create a summary of the competition, give me a summary of the data, generate bullet points with key domain knowledge and insight about the type of data. And then I can run that at the top of my notebook to have like a summary about the competition, which is generally I was doing manually for every competition when I prepare my notebook. But there I can use LLM to do that a bit quicker. So that's a small way I use them, but I have found that quite convenient. Discussion summaries. So on Kaggle, for every competition, there is a forum. And on forum, people will exchange about the competition. So generally, if you want to do better and learn more as you do competition on Kaggle, monitoring the EDA that are posted on the forum is important. And often there is a lot of great EDA shared there. But it takes a lot of time to read everything. So the way I started to use LLM is to try to, for each competition, have, for example, a sample text file where I will copy some of these forum discussions that I found interesting, put them together in a text file, and then when I use the LLM to generate code, for example, I can provide these key insights from the discussion. So first creating a summary and then providing this summary as part of my prompt where I generate code. And the hope is that I can then use the LLM to try to modify code template or generate code, taking into account ideas that are shared on the forum, which I found quite useful. I've been trying to use them to automate exploratory data analysis. So I use a sample workflow so far where I use Python to generate a dataset summary. So I created sample function to create a report into a JSON format about the dataset. So for example, number of outlier, missing value, description of the number of columns and rows. And then I provide this to the large language model to get a summary of the dataset. So in addition to the plot I generate, I will have a text format in a Markdown format where I will get a summary of the dataset from the information I provided from the function output. As well, sometimes I will request some domain knowledge insights. So for example, if it's a dataset about sales, or weather or something I'm not familiar about, I will give the dataset summary and request the LLM to give me some bullet points about interesting domain knowledge that might be relevant to the dataset. And then finally, I try to have code template I often reuse, that I then provide to the LLM. So the code can be modified to fit the dataset I'm looking at, and try to generate automated plot, which is working quite well. So I can generate my pie chart or box plot of the dataset automatically without regenerating the code each time. My hope being that from this code template, I will be able to vary the dataset, but still get a quick report to try to make this process a bit faster when I start the competition. Another way I use them is to try to create a baseline model quicker. So I've created code template, which I provide to the large language model as part of the prompt, as well with the exploratory data analysis report, in order to help the LLM create a code template, for example, for a baseline model. For example, if it's classification, I will ask the LLM to create the logistic regression, and based on the dataset summary I provide, it will create the code with the correct reference to the correct dataset and the link to the desired dataset, and then try to run a baseline model. And finally, I've been using them to try to give me idea about feature engineering, because that is often quite dependent on domain knowledge, which I don't always have for competitions that are not in my field. So I try to use them to go faster in terms of iteration of idea for feature engineering and testing as part of the workflow. So the case study presenting today is a sample Kaggle Playground series, which was this month about backpack sale prediction. So it was a small data set where your aim in this competition was to predict the sales of backpack based on the time of year and also based on the characteristic of the backpack, color, material, things like that. So the way I use LLM to create this report is I use LangChain. So today I will show you a sample workflow I've been working on, which is just based on a prompt template, where I can provide information to generate output about the dataset, generate code, and create insight. So then using LangChain, what I really like about this workflow is you can use it with different type of model. So you have an abstraction on top of the different model, and then you can easily switch between OpenAI model, Anthropic model, or even open source model such as DeepSeek, which means that your code, you only need change a little amount of code in order to run different type of model, which is quite convenient as some model will be better for something than other. So there on this competition, I was testing O3 Mini, which was new at the time. So I've been focusing on that, but at work, for example, I do project where I use cloud model, but that will be hosted directly in AWS, and then you can still use LangChain, which is compatible with AWS Bedrock, for example, which is very convenient. So there, in this code snippet, is the code I use to initiate the model. So there you define the model. I load my API key from the Kaggle secret. And then this first part will be the one that changes a little bit depending on the model. So if it is OpenAI, it's a chat OpenAI class. And then I have my template. So there, I instruct the model to provide analysis on the following EDA summary. Context is a variable where I store the EDA summary I generated from my code in a JSON format. And then I request to give key insight and observation in a markdown format. And it's very easy to switch model. So there I give an example of what the code will be if you want to use Anthropic instead. So you only need to change the name of the model, provide your Anthropic key, and instead of using chat OpenAI, you just need to use chat Anthropic. And then the rest of the code pretty much stays the same, which is very convenient. So for example, Claude 3.7 is a little bit better at coding. So with this type of thing, you can use, for example, Claude 3.7 when you are doing a coding task, but then if you are just doing an EDA summary, for example, cheaper model, for example, GPT-4o might be enough, whereas when you want to generate code, maybe you will go for the reasoning model, so Claude 3.7, O1, and O3, and as well as DeepSeek R1, for example. And then finally, what is quite nice about LangChain is now you can also run them locally. So if you have a GPU, for example, there I give an example, or you can use Ollama in a combination with LangChain to run a large language model locally. So there is an example where, for example, if you want to pull down a smaller version, a distilled version of the DeepSeek model, for example. So as long as you have like, for example, a laptop or a computer with like a gaming laptop with a GPU, for example, if you download the smaller model, for example, as the 8 billion parameter one, that runs okay. Or for example, even my laptop, like the fan go a little hard, but otherwise it's running, and then you can also use the same COM locally without having to change much of the code, which is very convenient. So in order to help me to create a summary from the LLM, what my idea was to generate a summary in a format that is that the LLM can understand. So for example, typically when human we do EDA, we just create quick and dirty plot, which we look at to get insight about the dataset. Whereas if you want to communicate with the LLM, my reasoning is like it's actually a lot more convenient if you can create data summary in a text format. And then storing them in the JSON format is quite convenient for LLM to parse. So I created a function to create a summary of the dataset in a JSON format. And then I use the LLM as part of the prompt to parse the JSON format and create a summary in a markdown format. And then I use the LLM to generate EDA code with or without providing a template to automate the process of plotting things of interest, such as univariate or multivariate analysis. I also try to use LLM to help with the domain knowledge. So for example, as part of the prompt, if it's something I have no knowledge, I will ask as well to not only do the summary, but provide key bullet point of the main things of interest or to watch for in the model. And with this part, one thing that's interesting is like as part of the LLM prompting, for the domain knowledge part, if you pair this type of workflow with techniques such as retrieval augmented generation, for example, you can select yourself your own knowledge base for this part. So for example, if it is a thing as sales, but you have like book, for example, that you know are relevant to your domain, you can also use retrieval augmented generation in combination from your prompt query the part of the book of interest, for example, to help you extract the domain knowledge from your source of interest to the report that the LLM is generating. So the EDA summary function I created for this is a simple one that accepts a data frame and then return a dictionary summarizing key metric. So for now, I do adapt it competition to competition. But for now, it simply compute overall statistics. So the number of row and column, the number of missing value for every column, the data type. Then I provide numerical statistics for the continuous column, so the mean, median, min, max, and the count for each category for the categorical column. And then I also add a part to evaluate distribution property. So are the variables skewed? Is there correlation between variables? Is there outlier in the data set? Everything that I know might be relevant as part of the workflow. And then my goal is to send this information to the LLM and then create a summary that I can quickly read over to understand the data set. So there I have simplified version of the function, and you can have the full version if you click the link at the bottom of the slide or from this QR code, which then will open my Kaggle notebook where you have the full version. But basically, it's a very simple function where I create a summary inside a dictionary, which I then save in the JSON format. So I record the number of row, column, I compute the missing value, everything you might do manually when you do EDA. Basically, I look at the type of each variable in the data set, count the missing value, describe the statistic for the numerical variable and the categorical variable, as well as compute correlation. And then I added a part for outlier detection as well as for skewness and kurtosis. Once I created this summary, so I created by running the EDA summary function on the Panda data frame dataset, for example. Then I convert the JSON format to a single string of text. And then I can inject this summary into the prompt. So there is my prompt I use. So I modify it to competition. But for example, I will do something like that, where I instruct the model to provide an analysis of the following EDA summary. I say the aim of this dataset on EDA is to understand how several variables influence depression. So that was for the depression competition. And then I said ultimately the aim is to build a classification model to predict depression. Then I give the context, which is the JSON summary. And then I say, okay, provide the key insight and observation. I then use the str output parser from LangChain to inject the summary JSON inside the context, which is taking place when you run chain invoke. And then the context is replaced by summary JSON, which contains the summary of the dataset in a JSON format. And then, because LLMs, they tend to generate all their output into a Markdown format, so it's quite convenient. I just need to run display and Markdown. and then everything will be formatted nicely in the Kaggle or Jupyter notebook output. So there you get a report like that, which is quite easy to read, and then I use them in combination of other tools for automated EDA. So there, for example, I have a general overview of the dataset. So then it tells me it's a dataset with 300,000 rows, 11 columns, with not a lot of missing value. It tells me which variable are numerical and which one are categorical. Also give me application for modeling on the different data types. So for example, it's telling me there is most columns are categorical with a limited of unique value. So if there is a lot of unique value, for example, it can raise a flag automatically telling you it's something to take care of when you create your model, for example, if you have some variable with a lot of unique value, which is something to take account if you do one-on-one coding or this type of approach. Also list the numerical variable, and it tells me like there is nothing that seems challenging there, so there is not an extreme queue on any of them, as it can open with the price, for example, or there is not a lot of outlier you need to reboot for the modeling, for example. Missing value pattern. So as part of the prompt, I often say like give me a warning if there is a lot of missing value. As well, I try to often understand if there is missing value, is it a situation where it might be missing value at random, or maybe it's not missing value at random, and then when I go in the modeling phase, it's something I need to be careful of. So there is telling that the cohort endpoint have about 3%. And then it can also give you idea about imputation strategy, or you can also instruct the model to give you count templates that relate to the summary as well. So there then I adapt this type of prompt competition to competition. So I started it to develop on the previous competition, which was a competition about predicting depression. And then I modify my prompt competition to competition. So the first part generally stays about the same. I just add a bit of context about what I'm trying to predict. So there it's a competition where I want to predict price. And then I give instruction, I try to give instruction to help me create Python code to perform the univariate analysis. So I give the tool I want the large language model to use as part of the code generated. So I say I want Seaborn and Matplotlib because it tends to work better than Plotly inside the Kaggle notebook, for example. So I do include in the prompt the tool I want to be used. I indicate as part of the prompt the name of the variable where I store my data. I give some instructions, so there's the ID colon is often not relevant, so I tell the model to drop it because I don't need that in the EDA. And I wanted for each variable for the univariate to have the histogram and the box plot side by side for numerical. And I wanted the box plot in orange and histogram of deep blue. I get this instruction, so this one is quite important. So there I'm trying to generate code that I can run directly in an execute function on Kaggle. So what I want there, I don't want the LLM to create code, Python code, but also text, because if I try to run that directly, I don't know where is the code, where is the command, then it will fail. So then I instruct to put the code inside the Python block. And then I can use the function to parse the output of the LLM and extract the Python code and then run it in an execute command. And then I've been experimenting lately when I do code generation. In order to make it more likely that the code generated is correct, I will provide a code template, for example. So I made a generic code template of code for histogram and box plot plotting. And then altogether, my aim there was that from the LLM, I will get an output, which is Python code, but is pretty much ready to run without creating an error inside the Kaggle notebook. So that is the code I used to run then the prompt. So I send the prompt from the template to the shelling prompt. And then during the shell invoke command is where I place my placeholder variable. So for the context, I put the summary JSON I created from my function earlier. And for code template, I create a code template variable where I store an example of code. So right now in the Kaggle notebook, I use a sample variable, but in the future, I will probably improve it by storing the code template directly in a Python file I upload to Kaggle, and then I can load in the code and send to the prompt. Then I display the result in a markdown format, so then I can see the Python code. And then that's the command I use to run the code. So I run the match to extract the Python code. So it's where it's important for me to say that I want the Python code to be in a Python code block. So then it's easy for me to just create a function to extract the code. And then I run a simple exec command to run the code. So I'm running on Kaggle. So sandbox environment there is better because then if you are exiting Python code, if you run it on Kaggle or if you run it on a server, it's okay. Then if you run it on the machine, you can be more of a security risk, like if you make a mistake when you create the prompt, you don't want to run by accident any Python code that, I don't know, like delete every file on your computer or something like that. So when I experiment with that, I always do it like on server that are low risk, so either Kaggle or any type of server where I know I won't have issue with that. But that's something to keep in mind for sure. And then if there is a problem, I just display a warning and then I can troubleshoot. So this plot there is an example of plot I've generated with this technique. So for this type of code generation, it works quite well. So the code run on the first test using the code template that is generic, and then the LLM basically replace the variable with the correct variable name I provide. I can also sometimes provide, for example, the path where the CSV is located, and the code will be generated correctly, loading the correct dataset, and then using the code template as well to make sure that I'm more likely to generate code that will run directly, which means I don't need to adapt. For example, we all like to have code template, for example, competition to competition. But then with LLMs, the advantage for me, I can just clean this template, provide them to the LLM, and some part of the code that are repetitive, competition to competition, I can let the LLM take care of those. So I like to organize my univariate and multivariate analysis, for example, in this way. So I like to have like my bar count, my histogram and both plots side by side, or my bar count and pie chart side by side. And then I just have to have a single template for that, and then pretty much competition to competition. My hope is this part, I don't need to code it anymore. I will just do it automatically. In parallel to that, I will open the Kaggle notebook after, but I also like to use other tools. So in R, for example, I like to use Data Explorer that do a lot of plots like that quickly and automatically. In Python, I like Panda Explorer and SweetViz. So then between the LLM assistant, this automated plot in the format I like, and the SweetViz and Panda report, I can save pretty much, I think, half the time on the EDA phase. You still need to spend some time, especially when it's not your domain, you still need to spend quite some time looking at the plot and looking at the report, and the LLM will miss some things for sure. But having this type of tool, you save quite a bit of time during this phase. So that's quite useful, and I hope competition to competition, I can do it quicker and quicker on this phase. For the multivariate analysis, I use the same approach. So I created a code template to create the box plot as well as scatter plot and correlation plot. And for those, I just provide the template, provide the information about the dataset in a prompt, and then the code is pretty much generated automatically, saving me probably half the time on the EDA phase. Um, the phase where I started to experiment with and I still learning to perfect it is I'm trying to use LLM to create baseline model. So in the workflow, generally, when I start to have a pipeline, I will often use LLM for the EDA, and for the modeling, I will have one baseline that is AutoML. So I like to use AutoGluon, for example, which perform quite well. But I also like to have like a baseline model, which is a simple one. So like a logistic regression or a simple random forest. And rather than using a code template, rewriting the code every time, I try to use the LLM to have code template I like that I can just provide. So if it's regression, I have my code template I like for regression or something for classification. And I'm trying to have a system where I can provide the code template and then let the LLM know where my data is located, what is the metric I want to use, and then take this information together to create a code that will run directly in Kaggle to create a Bayesian model. For that, I've been using the GPT-4o, O1 model, and I've been having good results, but it's a bit more challenging because the code you run will not always run at the first try, and sometimes the metric is not giving great performance. So one way I try to go around that is I create a kind of a double agent system. So I have a first prompt, which is to generate the code, which I would do with or without a template. So for example, we say, okay, I want you to create a logistic regression. There is a template on how I generally do my logistic regression. This is where I've stored my data set. This is a key variable, which I give from my EDA summary. And please write me a logistic regression code, and I want to use this particular metrics. And then I have a second agent, which is a code output analyzer. So this one does two things. There I code a second, I code a second LLM, which look at the output from the code. So for example, if the first code does not run and create an error, I send this error to the second LLM, as well as the code I've been generating. I say, okay, this is the code I have. This is the error message I have. Try again to correct the error and to make a code that run. And generally, I will run that in a loop, for example, where I will give, for example, 3 tests or up to 10 often, and I will say, okay, this is, I try to use that in a loop until I get something that works. It's a simple approach. One limitation is there I use only two agents. The second agent only knows the code from the previous iteration. Because one limitation, if you want to do it a large number of times, the problem with this system is if you have tried the code 10 times, then you have 10 code, 10 script, as well as, for example, 9 error message. And at some point, you will outgrow the amount of token allowed in the model. So far, I only use last try type of Basel, which is a simplistic way. And that's something I'm still working on to do something better, probably using full agent, for example. But for now, I use this sample system. And for most competition I've tried so far, I do manage to get into 3 time trial and error, I managed to get a baseline model that runs. Generally, they do not perform extremely well. They're often very simple model. And they won't be the one I use in the end for sure, but that allow me to get a baseline quickly. Instead of modifying a code template I already have, I basically let the LLM modify the template. So for those I use, at the difference from the EDA prompt, I use two prompts. So one is a system instruction. So there I said you are a coding assistant specialized in tabular data analysis. I give information about the competition. So there I said, here you might predict the price. And output valid Python code that runs end-to-end. So that I found is useful when you say end-to-end is I want to make sure that the code generated go from data loading to submission. So it's why I had this line and I found that at the system instruction, because it's a higher level prompt, I keep this one short, but basically that give the main role of the agent in that because it's a system instruction, there is higher priority than the template in the prompt. Then I create a template. So it's similar to the EDA, but there I provide more information. stored in variable. So there I give all the information that are relevant for the dataset. So the trend data path, I store the path to the trend data, the test data, the submission example, the summary I created earlier, the target variable. So there it's so then my hope is I can have something I can change competition to competition. And then path to the final submission file, so where I want the final submission file to be stored so I can submit to the competition. Then I describe the task, so train a model to predict, so there that's a target variable. So there I will store the name of the target price in there. Then I want them to generate a Kaggle submission. So I give the path where I want the submission file to be stored. And then I give the information about the metric. And then I store it in a variable that I can examine in the second prompt to try to determine if the code I generated is performing well or not. And then if it's below a certain threshold, I can try to run that in a loop, for example, 10 times, up to 10 times, hoping that one of the code generation will be one that perform well enough. So I try to optimize a bit the code using the loop system as well. There I instruct to run only valid Python code. I try to have it not create any, so I added this line to try to avoid the LLM giving that something that is a mix of command and Python code, because sometimes you will do that in plain language, and then it's a bit harder to extract the code and run it. And then that's the chain of prompt I use. So I provide the system message, which is the higher level one. So that's the one that takes priority. That's where you will put the role generally, like you're a coding assistant or your job is to do this. And then the human message is where I provide the template about the competition and the aim, and all the information about the data set and the task. Then I have a second agent, if you will, where it is for the repair prompt template. So there, that's the one I use to examine the output of the first code. And then I have two goals. One is try to correct the code if the first one just generated an error, which happen the more complex the data set and the more complex the baseline model I'm trying to create, the more often that happen. And the second way I use that is also to look at the metrics, and then I try to set a threshold where I will decide, okay, if the metric is not satisfactory, I'll try to run it again to see if the LLM can create a different version of the code that is improved compared to the last one, and give a better metric. And generally, I will do that in a loop. And after a certain amount of trial, I will just stop and just go with the one that has been generated. So there, in this template, that's the way I organize it. So I say the previous code caused an error or had unsatisfactory result. So that's on the metric analysis part. So there, the below is the code that was generated. So there, I store the code from the previous model. Below, I give the traceback or error message. So if there was an error, I store it there. And then finally, I give a reminder of the task. So there I say, you need to train a model to predict the price. You need to generate a Kaggle submission about the metric. And the rest is the same. So create only Python code. And then I try to run it. So that's the way I use them mostly. So summary and code generation. Summary, I have great result. Code generation, it works very well for plotting. For baseline, it's a bit more hit and miss. Some competition, I managed to have a decent baseline model from this method. Other competition, it was less good. So it works better for smaller code snippet generation. And if you try to create a full script, that's where it's a bit more difficult. But using reasoning model lately, such as O3, for example, O3 Mini, I have decent results. I started to experiment with Claude 3.7, for example. That's probably something I will try in the next competition. So I'm confident like I'm able to generate more and more code just from the LLM, and my aim is to have a collection of code template I can reuse competition to competition without doing much modification. Next step and improvement. So this workflow I've been experimenting did manage to save me quite a bit of time on competition, but it's still a simplistic workflow that I am still trying to improve and make it as a reproducible pipeline. So next step, I will try to use, although I've been doing effort to use LLM to automate competition. So there is a great article called AutoKaggle, where it's a framework with multiple agent systems that work together to understand the competition, look at the data set and create code. So it's similar to what I've done, but in a more complex and organized in a pipeline. So it's something I want to experiment with on the next competition. It seems very interesting approach. So that's a link to the paper. And there is a repository. So I can see you have many agents working for different tasks of the competition, working together to create some code, and they claim to get very decent result on Kaggle competition. So they have been focusing on tabular data so far, but it seems very promising. So they have one agent that focus on the background understanding. So as part of the workflow, you can check on the GitHub repo, you provide a summary of the competition in a text file. Then you have one agent that computes the preliminary exploratory data analysis. And for this, they use human in a loop workflow and different agents to plan an EDA analysis, so create a plan of analysis, a developer which focus on creating the code, and then an agent that is a reviewer that can then either send as an agent to the final agent, which is a summarizer, or if there is mistake, a bit like what I was doing, like looking at the previous model output, if there is mistake, you send back to either the planner to decide what is the way to troubleshoot, and then you send back to the developer to create more code, so working in a loop. Or if you still have error, then it can be sent to the human in a loop where you can set, where you can basically replace the planner agent. And if the LLM gets stuck in a loop, which can happen sometimes, if there is mistake, you try to fix them, they repeat this mistake in a loop. But by having this human in a loop system, you can basically edit the planner information. So you replace the planner agent and you give new instruction to create the correct code. And then you can go back in the summarizer agent. For the data cleaning, this one is quite interesting. They try to combine with retrieval augmented generation. So they have a list of tools that can then be used and reused for the data cleaning. So it's like an improvement of the code template I was trying to use, for example. And then when this is done, you can go to the more in-depth EDA, feature engineering, and then modeling. So it's several agents working together, the aim being that you can automate part of the work, and you still keep a human in the loop where you can provide information when the LLM is stuck in a particular step. So it's still extremely promising. That's something I've discovered recently, and the definitely next thing that I'm very eager to test for this month's competition that just started, which is the weather forecasting competition. And this is a link to the Kaggle repository for AutoKaggle. It's under MIT license, so everyone is free to experiment with. And yeah, that's the next thing I will try for this month's competition. And finally, another thing I started to experiment. So Matt Dansher, which is the person that developed the course, which I used to create the sample workflow I've been using, is going to the next level of what you can do with Longchain, which is to create agents, which is similar to what is used into the Kaggle agent paper. So there he is creating a series of agents that are under MIT license, so free to use for everyone and to modify. And there he's trying to create an AI data science team. So he has created an agent to automate exploratory data analysis. So like a more complex version of what I've been trying to do on my Kaggle competition, as well as automate modeling. And the aim is you can have these different LLM focusing on a several specific task. And by having them focus on a specific task, you are more likely to have them give you a usable output, so either on the EDA or the modeling part. So that's where I want to grow for the next step, to focus on the agentic workflow, still using LangChain, but trying to have different agents focusing on different aspects of the work, and I will try to combine that with retrieval augmented generation to have better domain knowledge, summarization as part of the domain knowledge, part of the EDA, which I think will be quite interesting, as well as part of the code generation, where I hope to provide my own code templates, and then I can control the output of the LLM better. In healthcare, in my domain, I've been very eager to explore the application of large language models. So where there is a lot of interest is some people have been wondering, can we use LLM for medical record processing? So very certainly, I think because there is a large amount of data that is processed, and LLM are very quite good at summarization. So that's something that seems promising. You have to keep in mind, though, there is quite possibly a lot of limitation with the hallucinations. So although they summarize a document well, you want to make sure that they do not give incorrect information. So that's a promising application, but that is definitely not trivial to implement. Bioinformatic assistants, so LLM are great at code generation, but they are actually not so great for bioinformatic coding. This is probably because as part of the training dataset, I suspect there is more, for example of tutorial for machine learning than tutorial for bioinformatic, probably. Bioinformatic tools tend to evolve quickly, so LLM are very good for code snippet generation, but if you ask them to give you bioinformatic script, they will often give you bioinformatic script that will be quite a bit outdated, so not necessarily incorrect, but that are not the last version of what you should do. So that's where I would like to use them to give to be better as a bioinformatic assistant for example, combining them with retrieval augmented generation, where you can store example of bioinformatic code or bioinformatic use. The idea being that if you have a bioinformatic data set, to be more able to use LLM to assist you with doing a faster analysis. At work, I've been using this model for single cell annotation. So that's one type of project I've been very interested. There has been quite a lot of interest in the field of automating the type of cell type annotation, which is charging part of analysis of this data set, where you have a non-cell type where you know a pattern of the expression, and then you have to determine what is the cell type. And inside the large language model, you have a lot of knowledge that is embedded that can be used for that. And also, more importantly, you can couple that with retrieval augmented generation, where you can create your own database of gene and try to use LLM to automate this part of the work. Literature review and summarization is something LLM do quite well. For example, Notebook LLM. The Google application is great at creating a summary of a PDF, and you can even retrieve exactly where from the PDF you got the information. So I found that quite useful and interesting. As in biology in particular, sometimes you need to read a lot of paper to be able to link a particular feature, for example, with a disease. And by using LLM, you might be able to summarize a large number of papers very quickly. So I think that's probably something that is quite interesting. And then finally, data analysis and interpretation. LLM are quite good at creating code snippets. So you can automate some part of the work quite well. So baseline modeling is full script is something that is still a bit more limited, and you need to have good data, spend quite some time to check the script. But if you stick to small snippet generation, then they do that quite well. So for example, if you want to do things such as data wrangling automatically, LLM will do that quite well. So generating panda code, for example, they will do it for you quite fast. As well for plotting, so generating a pie chart or generating a box plot, they will do that quite well. So that one way they can be very useful. You can automate part of the code generation that is simpler and easy to check. And then for the more complex parts, is still more complicated and you need to spend more time double checking. But I've been having quite a good result for data wrangling and plotting for sure. Yeah, that's all for the slide. I have also, so in the slide, I have provided you with the link for the notebook where I have implemented this code. So you can, on Kaggle, fork the notebook and experiment with the workflow I've been working on. And so I've been using that for, so if you go in my account, you will see I've been starting to experiment a few months ago on this type of LLM. So there is a depression competition where I started to use this workflow. And what I'm doing is like month to month, I've been rolling over the code I've been generating, trying to improve every time. So I've been improving the EDA summary function, as well as the plotting, automated plotting for the univariate and multivariate analysis. So if you're interested to see the template I've been experimenting with, you can find them publicly available on my Kaggle account. This is the one corresponding to this competition. What has been interesting on this one is something the LLM did not pick up automatically. On this particular set of competition, one thing that was picked up in the forum is on this data set, there was not sorry, there was not a lot of signal because there was some for the tabular competition, these are created automatically. And something the organizer did not identify is the way this original dataset was generated was simple random number generation. So for example, between normal characteristic, you will not get the correlation with price you will expect in a real dataset on this one. So for example, leather backpack may be more expensive, but there, because the number of leather backpack and the price was randomly generated, you were not getting any match between the two. And that's something you could see looking at the plot, but that's not something the LM picked up automatically, for example. But by using LM to help me monitor the forum is something I was able to pick up quicker and integrate in the notebook. And I was also able to create another synthetic data set, which I did with another LLM, where I tried to create kind of a better synthetic data set where you will have actual signal between price of leather backpack and correlating to your price, for example. So I think that was quite interesting because it shows that LLM are quite useful. They definitely do not replace the human critical thinking for sure. And so I thought that was quite interesting. They could automate something, but yeah, you definitely need still to be monitoring the forum and just combining that with your normal workflow where nothing replaces the domain knowledge and looking at the data for sure. But yeah, I thought that was interesting. Yeah, so I think that's all for the slides in the notebook, but I'm quite happy to go into question. If anyone has question about like the workflow I've been using, or if anyone want to share their own experiments they might have had with LLM, and for example, quality of output and how they ensure quality and how they use them in coding project or in data science.
Okay, William, thank you. A lot
welcome.
to unpack here. Okay, a lot to unpack. I will let's stop the recording run.
Okay.
Okay. So then we can have the question.